Hello everybody, in this video we're going to continue our exploration in enVision's Algebra 2 math book. We're going to look at topic 4, lesson 4, example 5, finding a rate. So Leah drives her car to the mechanic. Then she takes a commuter rail back to her neighborhood. The average speed for the 10-mile trip is 15 miles per hour faster on the train. Find an expression for Leah's total travel time. If she drove 30 miles per hour, how long did this take? Okay, so I'm going to jump over to my notepad. I have some things already set up. The first thing I'm going to point out is the triangle for distance, speed, and time. But instead of keeping speed as speed, I'm going to change this to rate. Because sometimes we might be working with things that are not linear, but we do know the rate. All right, so in this case, distance equals rate times time, or you could say that time equals distance over your speed, or your speed can equal distance over time, which is what we're going to use here. All right, so we have our car, we have our train. I'm going to put this into a table to help me organize this a little bit better. We're looking for time, so I'm going to make sure I fill in distance and rate, and from my distance and rate, I can find my time. So the distance we know is 10 miles. My rate of my car is going to be, I don't know, I'm just going to call it X. Well, I actually think they give us something up here, R and R plus 15. So R and R plus 15. So in all of this, my time would be 10 over R, and then this would be 10 over R plus 15. All right, now looking at this, we need to know the total time. So total time, I'm going to add both of these together. Okay, I have a common factor of R times R plus 15, because remember, this whole thing right here is a factor. This is a group. This is a team. This is a pair. We cannot separate them. So this R is a factor, and this R plus 15 is a totally different factor. This R are not related. Okay, so over here, we have 10 times R plus 15. Over here, we have 10 times R. Distribute those 10, so 10R plus 150 plus 10R, all divided by R times R plus 15. Looking at this, we get 20R plus 150, all divided by R times R plus 15. I'll pull out 10, but that doesn't do much for me. Let's see if there is anything else. 20 and 150. I don't think that, no, that doesn't work. Is it? No, I don't think so. No, it's 7.5. 20, 2 and 10. No, I think we're good. So we have 20R plus 150 divided by R times R plus 15. Now they want to know is what our time is. This is equal time. What our time is if our car was 30 miles per hour. So I'm looking at 20 times 30 plus 150 divided by 30 times 30 plus 15. See, 20 times 30, 2 times 3 is 60. So we have 2 zeros. Oh, no, sorry. 2 times 3 is 6. And then we have 2 zeros following. So 600 plus 150 divided by 30 times 40. 30 times 45. 1350. So what is that? 750. And then remember, this is miles per hour. 750 divided by 1/3 is 0.556. And I'm going to multiply that by 60, which is 33.3 minutes. All right, so let's go see how they did it. Oh, they said 5/9 of an hour or 33 minutes. All right, so use the appropriate tools. Use a table to organize information, help create an accurate model of the situation. So remember that distance equals rate times time. So rate times time. So that time is equal to distance over rate. All right, so you have one on the way to work. Juan carpools with a fellow coworker, then takes the city bus back home in the evening. The average speed of the 20-mile trip is 5 miles per hour faster in the carpool. Write an expression that represents Juan's total travel time. All right, guys, we'll see you in the next video.